Okay, Bismillahirrahmanirrahim. So, in our previous classes, we have already studied about potential energy, kinetic energy, and the conservation law of energy, right? And we have learned that whenever a body is lifted from the ground to a certain height, some energy is stored in it, and that energy is potential. We calculate the potential energy. And if we apply some force on the body, and due to that force, the body was at rest. Due to the application of force, it came into motion. So now clearly the body has some form of energy, and we call it kinetic energy, right? And we know how to calculate the kinetic energy. Also, we learned the equation. And then again, we also learned about the freely falling body. Okay, as I said, whenever a body is lifted to a certain height from the ground, okay, there is some potential energy stored in it, that is mgh. It is the potential energy. And the kinetic energy at the maximum height, it is zero, because at this point the body's velocity is zero. But if I lift the body, then what will happen? The body will start to fall down. Now, as it is falling down, the height from the ground will be decreasing. H will be decreasing, which will result in decrease in potential energy also. So as it will come closer to the ground, the potential energy will decrease. Now, according to the conservation law of momentum, energy can neither be created nor be destroyed. It can only be transformed from one form to another. So as potential energy is decreasing, this decreasing energy is not being destroyed. It is being transformed into another form of energy. What is that form of energy? It is kinetic. As the body was at rest, it did not have kinetic energy, but as we will leave it, it will have some kinetic energy now. From where that kinetic energy is coming? From the stored potential energy. So as potential energy is gradually being converted to kinetic energy, potential energy will keep on decreasing, kinetic energy will keep on increasing. And what will happen as it is coming down? What we said, potential energy will decrease, kinetic energy will increase. And just before touching the ground at this position, what will happen? The potential energy will be zero, because at that point the height from the ground h is zero. So potential energy at this point is zero, and whatever energy it had at this point, that is at the maximum height, that energy will totally be converted into potential kinetic energy now. So kinetic energy will be equal to mgh. We have already seen the proof of it, right? So from here, can I say something? That potential energy at maximum height, I wrote maximum in a shortcut way, kindly you do not do this, okay, is equal to kinetic energy just before touching the ground. So can I write it? Potential energy at maximum height is equal to the kinetic energy just before touching the ground. This is a little bit of revision of what we learned in the last class, right? So this is something you already know. Today we will be utilizing this relation. Okay, when? Inshallah, we will see gradually. Okay. Just before I start the solution of the problem, you can see that I have written a mathematical problem here. Inshallah, I will be solving it. Before that, do any one of you have any problem with this statement? Anyone has any problem with this statement?
Sir, can you explain it once again?
Yes, sir.
The statement.
A statement is a potential energy at the maximum height. How much is it?
mgh.
mgh equals to EP.
Kinetic energy just before touching the ground. How much is it?
mgh.
mgh.
So are they equal to each other or not?
Yes.
Yes.
Now it is okay?
Yes, sir.
Yes,
Okay.
sir.
So let us proceed. I will keep this line over here, okay? Let us just go through the problem. Okay, so a body of mass 5 kg. So we will be, তোমাদের জয়েন করা শেষ হবে না মনে হয় নাকি? Okay, so we will list up the given information. What is given? Given M mass is 5 kg. Okay, and it is lifted to a height of 30 meters. So H is 30 meters. So what is the amount of potential energy stored in it? Okay, so they have asked us to calculate EP. Potential energy is how much? Now we know. Please note it carefully that the solution has started from here. Okay, this is something I just wrote so that you understand, because there is another question, second part of the question, right? For that we will be in need of this line. That is why I'm not erasing it now. Okay, we will need it, but later. So when you start taking notes or write the notes in your notebook, after solution, start from here, and on the right hand side of the paper kindly draw this figure. Okay, kindly draw this figure. No need to write these things now, just draw the figure. Okay, and figure ta arekটু ওইদিকে আছে, আমি আরেকটু রাইট ফিগারটা ড্র করব এভাবে. This is the ground and this is the body which has a mass of 5 kg and it is at a height of 30 meters from the ground. Okay, just draw this figure. It is always better to give a figure because it shows that you have understood the scenario. Okay, so we know potential energy EP is equal to mgh, right? This is the way to calculate the potential energy. So we know the mass 5 kg, we know the value of G. Better to mention it here that we know G is equal to 9.8 meter per second square. So 9.8 into height, that is 30. So 30. Now as it is energy, the unit will be joule. So how much joule? Can anybody calculate and let me know the answer?
Yes, sir. 1470 joule.
1470
70 joule.
joule. Okay, clear?
Yes, sir.
Okay, so we are done with the first part of the question. A body of mass 5 kg is lifted to a height of 30 meters. So now what is the amount of potential energy stored in it? This amount of potential energy will be stored in it. That is, this is the potential energy at the maximum height, right? Okay, now let us deal with the second part. If the body is allowed to freely fall from that height, now we will lift the body and it will definitely fall on the ground. Okay, so with what velocity will it strike the ground? That means when it will come closer to the ground, just before touching the ground, or with what velocity it will strike the ground, that means what will be V is equal to here. At this point, what will be the velocity? We need to calculate the V. Okay, so how to calculate that? Let us see. So then after this, when we will start solving the second part, then you will write this. Okay, potential energy at maximum height. You will write, we know potential energy at maximum height is equal to kinetic energy just before touching the ground. So potential energy at maximum height, we just calculated it, that is 1470 is equal to kinetic energy just before touching the ground. What is the expression to calculate kinetic energy? Half mv square, right? Okay, so from here
Yes.
we know the value of m, that is mass equal to 5 kg. So we can easily calculate velocity v. So these two is divided, so it will be multiplied. 1470 is equal to m is value of 5, so 5 into v square. So 5, if I change the side, it will be 1470 divided by 5 is equal to v square.
Sir, where did 1/2 go?
ও আচ্ছা, এখানে মাল্টিপ্লাই করলে তো ভুলে গেছি না, মাল্টিপ্লাই 2 হবে. Okay, so multiplied by 2 then divided by 5. So how much will it be?
Sir, 588.
588. Okay, then
Yes.
to get the value of v, you have to root over both the sides. How much?
Oh,
24 point something?
Well, it is 14 root 3, sir.
14?
Root 3.
Oh, in decimal, how much it is? Decimal, I want the decimal value.
Oh, wait, sir.
তোমাদের যে as
It is 24 point, yeah, 24.25, we can say, or 24.248.
no problem. So
Okay.
24.25 meter per second. So with this velocity, it will strike the ground. Okay.
Yes, sir.
So anybody has any question? No. Okay. So related to potential energy, we will calculate another problem now. Let me write the question on the board. Okay. So this is our question. A boy of mass 35 kg given mass comma m is equal to 35 kg climbed up 30 stairs, each of 3 centimeter height. What does that mean? Let us say this is the ground floor. Okay, from here this is 1 stair, 2, 3, 4, 5. So it will go like this up to 30 stairs. Each stair is 3 centimeter. This is also another 3 centimeter. Okay, so it goes like this, each of 3 centimeter height. What will be the potential energy stored in him? So if I want to calculate the potential energy, definitely I need to know EP is equal to mgh. M is already given and G 9.8 we know, but what about the height? We need to know the height. Okay, so let us try to find out or understand how to find out the height from this type of question. When he was on the ground, let us say the boy is on the ground now, his height is 0. When he will climb the first stair, he will climb the first stair, then he will be at a 3 centimeter height from the ground, correct?
Yes, sir.
Yes.
So when he goes to the second stair, it will be he will be at 2 into 3 centimeter height from the ground, right? 3 centimeter, 3 centimeter, 2, 3 centimeter high from the ground. So when he goes to the third one, 1, 2, 3, 3 centimeter height from the ground. So total 9 centimeter, correct? So in that way, if he rises 30 stairs, so can I say that he will be at a height of 30 into 3 centimeter from the ground? Can I say it?
Yes.
Yes, which is
Yes.
90 centimeter.
90 centimeter.
Yeah.
With each stair rising, he is rising or he is taking himself up by 3 centimeter. Or we can say that the distance from the ground, the height from the ground is increasing by 3 centimeter. So when he will rise total 30 stairs like this, what will happen? He will have raised himself to a height of 30 into 3 centimeter, right? Okay, একটা স্টেপের জন্য 3 সেন্টিমিটার, তাহলে 30 টা স্টেপের জন্য 30 into 3 centimeter, 30 times, right? So now you have to be a little bit careful, because many students, what he will do, M it is 35, then G it is 9.8, and the value of H they will put as 90, but there is a problem with the value 90. Can you tell me what is the problem? Why cannot we use the value 90 here?
Because, sir, it's in centimeter.
Centimeter.
Yes.
Now what is the problem using centimeter here? Why we
So
cannot
we have to
It's
change.
meter. We have to change in
Yeah.
meter.
In meter,
Meter.
yes.
meter? But why? It can mandatory.
Because the gravitational value is 9.8 meter here.
Very good. It is in meter per second square here, right? It is in meter per second square.
Yes.
Why? All the distance need to be in the same unit. If it is in meter, then you have to take this one also into meter. So centimeter to meter, how can we convert?
By 100 divided
By
by 100.
100.
Divided by 100. So 90 divided by
0.9. 0.9.
2.9 meter.
Okay.
So we have to put the value of height as 0.9. Then you can calculate and write the answer.
308.7.
308.7 and it will be joule.
Yeah.
Okay, as we are calculating energy, so it will be joule. Okay. Okay.
Okay, sir.
So whenever you are running to the roof from the ground floor, know that there has been some potential energy stored in it. Now, how you can feel the potential energy? Don't do this, but you will feel it when you jump from the roof. Okay, you will see that you are at rest, but now you are having some velocity. As you are in motion now, you are falling to the ground. As you are having a motion, what will happen? That depicts that you have some kinetic energy. Now, from where this kinetic energy came? From the potential energy that was stored in your body when you ran to the roof. Okay, so don't do this. Okay, I'm just saying.
Sir, can you move aside? I want to take screenshot.
Boli nahi ki?
Move aside.
Okay. Whenever you say to move
Please
aside, say
access
please.
Fatima. Okay.
Done?
Yes.
Okay. Do I need to explain it?
No, sir. It's so easy, sir.
No, sir, yeah. Just we need to put the values and
If
find
there
out.
is anyone who feels that I need to explain it, then kindly raise your hand. Is there anyone for whom I need to explain it? All the values are given. I just put it into the equation and we found the answer. Very straightforward. Okay, nobody raising hand. That means you don't have any doubt. Okay, mashallah. So we have 7 minutes left. So we can start the topic of power. Okay. So till now we discussed about work and energy. The name of this chapter is work, energy, and power. So we are done with the first two topics. The first two topics was almost the same, right? Because we said work and energy are of the same amount. How much energy you have, you can do that amount of energy, or you can say that how much work you can do is equal to the amount of energy you have. So work is equal to energy. But what about power? What about power? So during calculating work and energy, we did not take into consideration the how much the time the people are taking to do the work, right? If you remember, we used an example that two persons are doing same amount of work, but one is taking less amount of time and the other one is taking more amount of time. Then I asked you who has higher energy. So we had different of opinion, but Fatima gave the correct answer. She said that both of them have the same energy. Why? Because both of them did same amount of work. So you can see that we did not take into consideration the time taken to do the work, right? So when will we will consider the time? Whenever we are calculating power. Okay. So now we are going to discuss about power. Okay. So this is the definition of power, the rate of doing work with respect to time. Okay. At what rate you are doing the work. Okay. If someone is doing the work in less amount of time, we will say that he is doing it faster. So he has higher power. And if someone is taking longer amount of time, we will say that he has less power because he's slower. Okay. So from this type of equation, you should be able to, tell yourself something that always remember the relationship between the numerator and this one is same. And the relation between the denominator and this one is the opposite. Now, what do we mean by that? If you do more amount of work, that means you have higher power or lesser power. If you do higher power, very good. That means if you do more work, you can say that you have greater power, right? But to do the same amount of work, if you take more amount of time, what can you say about your power? Your power is higher or lower?
Lower.
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 If your power is greater, then you would have taken less amount of time to do some work, correct? So that is why the relationship between P and T is opposite, okay? So sometimes in MCQ, you might be asked if a person takes more amount of time to do some work, the power will be less, power will be lesser, okay? So this you need to understand. See, with the numerator it has the same relation. If this is higher, this is also higher, but with the denominator it has the opposite relation. If this one is higher, this one will be smaller. If this one is smaller, then this one will be greater. Okay, now I did not write the unit and dimension because I want to hear it from you. Okay, I want you not to memorize. I just want you from the equation. By looking at the equation, you should be able to tell me the unit. Can anybody tell me the unit from here?
Sir, joule, meter per second.
Yeah.
Why meter per second? It is
Uh,
work. Work has a unit of,
joule.
Joule.
okay. And what is the unit of time?
Second.
Seconds. Seconds. Oh, okay.
Joule per second, right?
Oh, yeah. Sure.
And
Yes.
joule per second, it is also noted as watt. WATT. তার মানে হচ্ছে কি 1 watt is equal to 1 joule per second. So we can give the definition of 1 watt from here. If a person can do 1 joule of work in 1 second, see 1 joule per second. Per second mean in 1 second. So in 1 second, if you can do 1 joule of work, I can say that your power is 1 watt. Okay. So এই জিনিসটা একটু আমরা এখানে লিখি। অনেক সময় 1 ওয়াট এটার ডেফিনিশন লিখতে বলে। সো এটার ডেফিনিশন আমি চাই তোমরা বুঝে লিখবা, মুখস্থ করার দরকার নেই। ওকে, এখান থেকে আমরা লিখতে পারবো if a person can do 1 joule work in 1 second, then his power is 1 watt. From here you can write the definition, or sometimes I give you a question like this: what do you understand by 50 watt? Okay, if I give you 50 watt here, then you will write it 50 joule per second, correct? So that will mean 50 per second. That means per second means in 1 second how much work he will be doing now?
50.
50.
So that time we will write if a person can do 50 joule of work in 1 second, then his power is 50 watt. So মাঝে মাঝে কোশ্চেন জিজ্ঞেস করি না, what do you understand by 50 watt অথবা what is the significance of 50 watt? এই ধরনের কোশ্চেন 2 মার্কের জন্য তোমাদেরকে জিজ্ঞেস করতে পারে বি তে। তো সেখানে তোমরা এই সিম্পল একটা লাইন যদি তোমরা লিখতে পারো, you will get 2 out of 2. Many people, in the answer of this, they write so many things. They write 1 page. Not needed. Science is not like other subjects where you need to fill the pages. No, you write the correct thing, main thing, what you have been asked in 1 line, you will get full number. Okay, so if you are asked what is the significance of 50 watt, you can say that 50 watt is equal to 50 joule per second, which means if a person can do 50 joule of work in 1 second, then his power is 50 watt. If you just write this 1 line, 2 out of 2, no problem. Okay, so I hope the concept of power you have understood.
Yes, sir. But can you tell the dimension?
Oh yes, the dimension. Let us recall what is the dimension of work. ml square p inverse 2, if you remember. Correct? This is the dimension of work. Now this one is being divided by another t. So এখানে t শুধু আরেকটা বেড়ে যাবে, t inverse 3 হবে, because নিচে divided by যদি করো তাহলে তো inverse এটা বাড়তে থাকে, তাই না? So it will be ml square t inverse 3. ml square t inverse 3. This is the dimension of power. So they are quite interrelated. If you learn one, you will understand how to find out the others. Okay, so এটা মুখস্থ রাখার দরকার নেই, জাস্ট এভাবে নিজেকে এক্সপ্লেইন করো।